When we look at the small intestine and the large intestine, just by looking at them, we can start to see some differences. Okay? Both are sites of absorption, but they absorb very different things. Okay? The large intestine is in charge of absorbing water and minerals. So when we look at these two organs, okay, they're physically and visibly very different from one another. All right? The small intestine, if we look at all this, the small intestine actually has a diameter of about 1 inch. Okay, so if we look at that, it's got an external diameter of about 1 inch. Whereas the large intestine has a diameter of anywhere between 1.5 to 2.5 inches. It is a lot larger, okay? The small intestine is a lot longer than the large intestine. All right, this can be 6 to 7 meters in length, whereas this guy is about 1.5 to 2 meters in length. Much different in size and structure, but they're both the site of absorption. So in order for food to be absorbed in the small intestine, all right, the small intestine does not have a very large surface area. If the diameter of this is only 1 inch, if it's only 1 inch in diameter, that's not a huge surface area to ensure that the vast majority of our nutrients gets absorbed. And think about this. The big three in terms of our nutrients, our energy-giving nutrients, are all absorbed in the small intestine. Amino acids, carbohydrates, and fats are all absorbed there. So this can be kind of, wasteful if we don't get everything out of the chyme as it's moving along the small intestine. So in order to solve this problem, we've actually evolved a very interesting structural setup on the inside of the small intestine. And that is the evolution of structures known as villi. So in the inside here, what we actually see is we see this actual extension of surface area. The small intestine has evolved to maximize its surface area on the inside by the development of these projections that actually come into the center of this tube, and they almost look like fingers. And each of these fingers is known as a villi, okay, or a villus. So we have here, and there's another one, so on and so forth. Okay? Now all of these projections increase the surface area of the inside of the actual small tube. If I was to take this villus, in plural villi, and actually make it a lot bigger, we would see that the projection itself comes out like this and goes on. And on the inside of the actual tube here, the small intestine, we see that the chyme is exposed to a lot more tissue than it otherwise would be on or in a tube without any villi. Okay, so all of this chyme is being exposed to absorbable areas. Because here's the deal about the villi. They're very, very thin skinned projections, these little fingers. And very close to the actual surface here, we've got a tremendous amount of blood vessels. Okay, very, very close to the surface. And this is where nutrients like carbohydrates, C6H12O6, actually pass this barrier and go into these blood vessels. This is where amino acids pass this barrier and go into these blood vessels. All right? Now, what's really, really cool here is to actually even increase. Because remember, if this is about, 1.5 centimeters or 1 centimeter long, we're talking about molecules that are getting absorbed here that are microscopic. We cannot see carbohydrates, even though they can be very big molecules. We cannot see amino acids or fatty acids with the naked eye. So if this villus is 1 centimeter in length, can you imagine how many more molecules or nutrients are being exposed to absorbable surface, okay, with each of these projections? And the really cool thing here is that to even increase it still, on the surface of these little guys is we've got these tiny little, these tiny little microvilli, which act the same way as the villi do, in that they increase the surface area. Okay, and what ends up happening here is if we look at the surface area of this, remember this is my tube right here. If I was to actually lay this out, the tube is this long, let's say. Okay, that's the absorbable surface area. But with the villi, the tube ends up actually being this long. So from here to here of absorbable surface. When we actually talk about that increased surface area that the inside of the small intestine has because of villi and microvilli, what we're implying is that every one of these folds means that all of the surface on the inside of these folds is areas or are areas where this microscopic little nutrients can actually pass through a very thin barrier and make their way into the bloodstream. Okay, so as the chyme actually makes its way through this, okay, all of these areas here, chyme is actually flowing through, and it's being pushed along by peristalsis because surrounding the outside of this tube is a layer of smooth muscle. Okay, we've got this slightly thicker layer of smooth muscle, and this is like one ginormous Mr. Freeze. That chyme is just getting pushed along by small little muscular contractions that you and I don't feel. We don't know they're happening. Okay, and the really great thing about the fact that the small intestine, the absorption part of the small intestine is over, it's over 6 meters long, is that all of the potential nutrients get absorbed. By the time this soupy mixture makes its way through all 6 meters, there are very few carbohydrates, or I should say monosaccharides, amino acids, fatty acids, and vitamins that are left. Everything that the body needs. And even if the body doesn't need excess vitamin C, it'll absorb everything that it can possibly get. And then it'll find ways of getting rid of its excess in another way. Okay, we're very selfish, and we're gluttons when it comes to nutrients. Okay, and you are a glutton when you take more than you need. Okay, in French we say, on a les yeux plus gros que l'estomac, our eyes are bigger than our stomach. All right? And your body takes all of these nutrients in it and it absorbs all of them so efficiently, and they make their way into the bloodstream, and then your body deals with it. It deals with whatever it has in excess and gets rid of whatever it needs or stores whatever else it needs. Is that super efficient? No, it's not. But that's how we've actually evolved. Okay? Now, at the end of this pathway, food then goes from the small intestine to the large intestine.